Hello guys, in this video we will see how to design a dipole antenna, okay, using CST Studio. So see, we are seeing one of the experiments of the antenna theory and design subject, okay. So if we see our syllabus, the experiment title is Design and Simulation of Dipole Antenna and Measurement of Characteristics of the Same, okay. Uh, so for this, we have to use a CST Studio for the experiment. So I will open the software and go through the steps. So now since it is only used for educational purposes, so I have used that same license for the educational purpose. Okay. So I'll say OK here. Okay. Once we have entered the software, we have to select new template. If you want, you can choose a previous template, but for a fresher or for a new beginner, we can say create new template. Then I'll say microwave and RF or optical because we are working on antenna. So I am choosing this one. Okay. Then I will select antenna because I am designing an antenna. So I'll select antenna and say next. Then see the type of the antenna what we are using is a dipole antenna. Now dipole antenna is actually in 3D, if you see, is a wire which is having some diameter or else a radius. Along with it has going to have some length. Okay, so that is why we have chosen wire as the workflow. Okay, then I'll select next. Then see, we are working on the time domain calculations now, so I will be selecting time domain. Then I said next, uh, keeping all these elements as the default because since is a standard element, gigahertz is for what we are planning. Whatever antenna design we are doing it is for 2.4 gigahertz. Okay, so I say next. Okay, now this is important. So what is the frequency range what we want to test it for? So I want to test it from 1 gigahertz up to 3 gigahertz. Okay, and I want to analyze all these elements. What? That is E field, H field, far field, power flow, power loss. It is nothing but the E plane, H plane, and the polar plot and the entire polar plots. Okay, and how the power flows. Okay, then I say next. Now you are going to give the template name. So you can give any template name for your use. Okay, I say dipole underscore ant. Okay, and say finish. Okay, so we have just created a template now, and we have not created our CST Studio file. Okay, so CST Studio is open now. Okay, this is how the mesh will look. Just be careful that when you are scrolling, if you do up scroll, it will zoom out. If you down scroll, it will zoom in. Okay, if you want to come out of the zoom, then you can use this command, that is reset view space. So yeah, if you want to reset the entire field, then you can click on this command, that is reset view. Okay, if you want to rotate, okay, you can rotate it like this. So this is rotate option, this is dynamic zoom, this is rotate in plane. So which plane you want to rotate? So for example, in this plane, or whichever plane you want, in that plane you can rotate. Okay, this is one more option, that is move. Okay, and this is zoom, how we pan and zoom, like whatever area we select, that it will get zoomed. So I'll again go back to the original, that is reset. Okay, and rotate in plane, I'll just try to keep it normal. Okay, now the next step is modeling. In modeling, we have to select the cylinder because, as we have said, the wire in 3D looks like a cylinder. Okay, so once I select this, it is asking me, see here, it says double click the current point in work plane, press escape to show the dialog box. So I'll just click once the escape button. Okay, now see here, it is whatever it is showing is the cylinder. Okay, and it will be a component now. So what I'll do is I'll give it a name as dipole. Okay, and now this is the orientation. So since I am keeping it in the Z axis, so I have kept it as Z. Okay, if you want to keep it on Y, you can keep it on Y, but for my study I am doing it for the Z axis. Outer radius I am keeping it as R, inner radius I'll keep it 0. X center and Y center I'll keep it 0. Okay, and Z minimum, this is important. This we have taken it as how much? We have taken it as L by 2. Okay, now why it is L by 2, I'll just show. Okay, so we will see it, keep it as minus capital L by 2 to maximum value is L by 2. Okay, let the segments be 0. Okay, and now this components I'll make it as name as dipole. Okay, now the material what we have to choose for this dipole is copper, that is annihilated copper. So I'll load it from the library. So I'll say load from material library. Then in the search bar I say copper annihilated. So I'll select this one and I'll say load. Once I say load, I have to click on press OK. Now it will ask me for what is the value of R. We had typed here something as R. That is what? That is the radius of our cylinder or the wire. Okay. So what is it? We can keep it as 2 mm. Okay. We'll keep it as 2 mm. So I am entering it in the second here is, see, first is R, that is what is we had given here. So that is why its value is being asked from us. So I have kept it as 2 mm. Description is for our understanding, which will be shown here. See here, it will be the name, here expression, its value and its description will be shown. Okay. So that is why I say okay. Okay. Then it will be asking me for what? The values of L. That is what? Length, because we have made it as minus L by 2 and plus L by 2. So length we have to give. So the length what we have given is 59.8. Okay, I'll write it here as 59.8 mm. Okay, now why it is 59.8 mm? Because we have got a standard formula as capital L is equals to 143 divided by F. Now since our frequency, that is the frequency what we want to design the antenna is 2.4 gigahertz. Okay, and through this formula if we just divide, we will get the value of L as how much? It is coming around 59.8 mm. Okay, it will come around 59.8 mm. So that is why we have kept the L value as 59.8 mm. Of course it gets divided by 2, and that is why we see this antenna like this way. Okay, so it is technically 29.9 mm on this side, on the positive side of the Z, and 29.9 mm on the negative side of the Z. Okay, so this is how the antenna will be placed. Okay, so once we have completed this, we will have to create a gap. Okay, so for that I will do one more cylinder. Okay, so I'll click it as cylinder. Okay, and I have to press escape. Okay, and I'll say gap. Okay, again the outer radius I will keep it as R. Okay, because it is to be 2 mm only, so that is why it is 2. Okay, now Z minimum is different. Okay, now Z minimum we are keeping it how much? We are keeping it as minus gap by 2, and maximum value is gap by 2. Okay, now once we have done this, it should ask me the value of gap. So I am keeping this component name as gap. Why gap or the name? Because I'll just show it. Okay, and here please understand the material should be vacuum, because we are creating a small slot here in the antenna. Okay, then I say here okay. Now yes, as I said, we had given here element as gap, so it is asking me what is the value of that gap. Here I'll make it as 3 mm. Okay, I'll say it as 3 mm. So it is technically 1.5 mm on the positive side and 1.5 mm on the negative side. So I say okay. Now it is asking me to where should I intersect. So I say cut away highlighted shape and say OK. Once you say this, you see that the antenna gets cut. Okay, the antenna is cut over here. Okay, so the antenna is cut with a 3 mm gap, 1.5 mm on the positive, 1.5 mm on the negative side. Okay, I'll reset it. Okay, now further what we have to do is we have to go for fix. Okay, then I say pick edge. Okay, in order to select any of the edge, okay, when you go on the design, it will get highlighted with the red color. So if I select this, it is not getting highlighted, but here when I come over here, it gets highlighted. Okay, so I'll double click on that. Okay, now see, I have to select both these faces of the where I have made that slot. So I have selected one. I have to select one more edge now. So I'll select pick edge. Okay, and I'll select this one more edge. Okay, so one click it will not work. Double click we have to do, and then it will get selected. So now maximum part of the work is done. Okay, then what we have to do is go to simulation. We have to select discrete port. Okay, discrete port, and see here the impedance. See, we want to calculate the S parameters and other elements. So for S parameter, I have selected the ohms as 50 ohms. That is what is the impedance. Okay, and say OK. So once this is done, we have to go for simulation. Okay, I'll say home and I'll say start simulation. So once you click on this, it will take hardly a few minutes. Now this will vary based on your computer or the laptop. If your laptop is having a graphic card, or if it is having more amount of RAM and SSD, it is going to calculate or do the simulations faster. And if you are having a lower amount of RAM, or if it is a non-SSD system, it will be a quite slower process. Okay, so that is why the speed will depend on the system. Okay, so now after a couple of minutes we can see the simulation results. And one more thing, we will just save this file. Now since it is showing me as untitled 0, I forgot to tell you all how we had to save the file. Okay, once the simulation is completed, we can see the saved. Okay, so here it has completed the simulation steps now. Okay, warnings. It is showing me 4 warnings which I can ignore. Okay, so these 4 warnings I can ignore. That's not a problem for us. But if there are errors, then we have to surely go and edit those, or prompt reply for those errors, or we have to solve those errors. Okay, so now all the simulation results are stored in the left hand part over here. Okay, for example, far fields. Okay, I'll select this one, that is what, 1 gigahertz. Okay, and I will zoom out. Okay, now if you see, I'm just rotating it now. Okay, so if you see, it's a donut shape kind of a thing, if you can say, or if it is a sphere. Okay, so this is a dipole antenna simulation at 1 gigahertz, similarly at 2 gigahertz, similarly at 3 gigahertz. Okay, now one thing what we have to what we can observe is, at 1 gigahertz, if we see, the size or the length of this lobe, or the diameter of that lobe, was a bit higher. At 2 gigahertz it got lower, 3 gigahertz it is getting lowered. So further on it may happen that at the higher frequencies it will get lowered. Okay, but this is one quite small analysis what you can see. Okay, now similarly you can see the 2D fields as well. So I am choosing E plane, okay, at 1 gigahertz. Similarly, if I want to see the H plane at 1 gigahertz, I'll be getting the output. Okay, or else if I want to see for 2 gigahertz, it's for 3 gigahertz. Okay, So see here, I said that the maximum of the experiment is done. I just wanted to show one or two another elements. So first thing is we have to save this, okay? And I say just Control S, okay? I am saving in my default folder. So I will just say dipole underscore test underscore 2.4 gigahertz, okay? And I say save. Okay, it is saved now. Okay, now one more thing what I'll do is at the far field at 1 gigahertz I'll select this one or any of the frequency if you want, and you can say right click far field properties. Here I'll select plot mode, then I'll select gain, and I'll say apply and say OK. Now once I do this, see here, it will be able to show me the maximum and the minimum values of the decibel or the gain what I am able to have. Okay, so for example, in the 1 gigahertz range we are having the low, that is the highest gain as 0.778 dBi, while the lowest is minus 40 dBi. Okay, similarly if I go for 2 gigahertz, it is maximum of 2.01 dBi and minus 38 dBi, that is the lowest. Okay, similarly for the far field, it is the highest is 2.44 and lowest is minus 37.6. Okay, so this is how the far field elements or the other parameters what we can choose. Now one more thing what I can show for you all is, see here, we had designed our antenna. Okay, so what I can do is I can create an array of the antennas. Okay, how? I'll just show in a minute. Okay, now you see here, I said I just want to show one or two steps. We have already saved the files and we have done the tests and we have got the results. Okay, now I'll show you some other elements. Okay, see here, we have got something called as components. If I choose on this dipole, I'll get to see the dipole. If I choose on the gap, I will be able to see the gap. Okay, technically. Okay, and I'll just say rotate, you can just see. Okay, so whatever component is there, that is getting highlighted. Okay, now what if I want to have an array of the antennas? Okay, then what I can do is I'll select on modeling, then I'll select transform, then I'll say translate. Okay, now here it is important, I'll select copy. Okay, and then before that I made a mistake. Okay, so that is transform, that is translate. Now see here, it is showing me the directions in which I can copy or else make other replication of the antenna. So I'll choose one direction. Okay, for example, I'll choose this direction. I say copy and I'll say OK. I say store the current results to a new file, because I am already already working on my previous file. So I say store the results to a new file and I say OK. Okay, and I'll just say test underscore 1. Okay, for example, and just say save. I say okay, it is already done. Okay, then let us see now. I say translate, I'll choose the direction, any direction you can choose, and say select copy, say okay. I select translate, I choose the direction, I say copy, choose the direction, I'll drag and place it, copy, say OK. Okay, I say escape, and I say escape. I can see that there is dipole 1, there is dipole 2, there is dipole 3, there is gap. Now why did this happen? Because already when I had pressed, I didn't move those antennas, so already the dipole got placed over each other. If you have done this mistake, you can say undo. Okay, and that's it. So I am again at the square one. So you can see there is only one dipole and there is one gap. So this is how you can choose to have arrays. I'll just show once again if you want. So I'll just select the dipole. Okay, I said transform, I said translate. Okay, before that I will just choose a direction in which I want to make my copy. Okay, so I'll say copy. Okay, I'll choose the direction. I'll just drag and place it, and I'll say okay. Now you see here there are two antennas which is of the same property or the same construction is ready now. If I want to transform or create one more, I'll select copy. Okay, I'll choose a direction. I'll just drag it and say okay. So now if you see, I got how much? About three antennas are available. That is dipole 1, dipole 2. So, and this is the original dipole. Okay. So this is all with this experiment. Yeah, that's it. Thank you.